Okay, we're going to do a quick review of inverses, the last few sections. We're going to practice where you have to graph and find the inverse. We'll do it two ways. We're going to take a look at the problems that say where you algebraically have to show if something inverses, and then we're also going to look at one that starts off as a radical and find its inverse. So let's go back and start if it's linear. If you have a given graph and you know some clean points, you can see those on there. Remember that you can reverse those points. So if this is graph y and this is the point 3, 4, on my graph of y inverse, I'm going to have the point 4, 3. If this is the point 0, 2 on one graph, I'll have the point 2, 0 on the other. If the point is negative 3, 0, I'll have 0, negative 3. And that's enough that I can connect, find my slope, that is my inverse graph, the green one. And I also can now look at my y-intercept is negative 3. So if I'm thinking of how I get the equation, my slope is up 3 over 2. So I have a 3/2 x minus 3. Also, if I think about where they would cross on the line y equals x, they would cross somewhere out here. They're mirror images across that line. Next one is algebraically determining two things are inverses. So I'll take this example here. If f of x is a function, it means I do 5 times something minus 5. G of x is a different function. It means that I take something, take 1/5 of it, and add 1. So what I have to do is put each function in. If I take f of g of x, I have to substitute 1/5 of x plus 1 in this equation. I distribute, and I get x plus 5 minus 5, which is x. That's a good thing. When I go in the opposite direction, if I plug in f of x, I'm plugging in the expression 5x minus 5, this one from right here, and then I distribute my 1/5. I get x minus 1 with a plus 1, which gives me x again. Because I got x in both directions, I say yes, they are inverses. So in order to show algebraically, you have to show both directions. Plug each function in. If you get x both times, that's a good thing. If you don't get x, anything other than x in that location, you say no, they're not inverses. And the last thing is when you have a radical. If you start with a radical graph, your inverse is going to be that funny kind with a restricted domain. So you're going to have a second part. It's going to be half of a parabola. So if my main function has a starting point at negative 7, negative 4, and I know that it's going to graph, let me count here, sorry about that. If I count right 1 up 1, and right 4 up 2, and right 9 up 3, I have a pretty accurate graph. I can remember what those points are if I'm trying to get my inverse as well. If I know that my starting point was negative 7, negative 4, I can find negative 4, negative 7, and I can get my starting point for this graph. If I know another point was negative 6, negative 3, I can find negative 3, negative 6. This point is negative 3, negative 2. So I'll find negative 2, negative 3. This point over here is 2, negative 1. So I'll find negative 1, 2. The arrow is on this end. So there's my arrow for my inverse, and it's going to slide up. Now remember what this is. This is the right side of a parabola, only the right side. And this x value right here is negative 4. So I know that I'm only going to do my parabola greater than or equal to negative 4. This parabola's vertex is negative 4, negative 7. So if you happen to remember vertex form, you can plug it in that way and say x plus 4 squared minus 7. Also look at your domains and ranges. The domain on the first function went from negative 7 to infinity. That became the range on the second function, right? It started at negative 7 and went up. So negative 7 to infinity there. The range on the first function started at a y value of negative 4 and went up. So I'm going to say negative 4 to infinity for the range, which then should become the domain. Did it? Yeah. The domain there started at negative 4 and went to the right. Now say you didn't remember how to do the parabolas. Remember your technique for finding inverses. It says switch x and y. I'm literally rewriting x in y's place and y in x's place. I'm going to add 4 to one side. but y is under a radical, so I'm going to have to square both sides. And remember, this is a good thing. Don't FOIL. Just keep it like that. So I have y plus 7 by itself. I don't want 7 there. I want to subtract it over. So I have x plus 4 quantity squared minus 7. Just another algebraic way to get that function. Good luck.